So you should have this packet from your crew teacher in front of you. And if you are virtual, right, you have that link on the agenda for you to either print or follow along with the lesson. So at the top it says dot plot worksheet, which is really the same thing as saying line plot as well. Okay. And so let's talk about a line plot. A line plot, first off, you can see a couple of examples on the front page here at number 1 and number 2, and we're going to go over those problems here in just a minute. But as far as a definition goes on what a line plot is, let's see if I can zoom in here a little bit. And we're just going to write this at the top. So a line plot shows the frequency of data with a number line. Line plots show the frequency of data with a number line. And so you will see with these examples here that that's exactly what we have is a number line. So we're going to start with number 1 here. Number 1 talks about the students in one social studies class were asked how many brothers and sisters, siblings, they each have. And the dot plot here shows the results. So first off, on these number lines, really, you should have a title at the top. Typically, that's what you see. So I'm going to have you write in a title, number of siblings. Number of siblings. Now, if this class was asked how many brothers and sisters they each have, and it's represented here on this line plot, well, what are you looking at? How do you read it? My first question would be, well, how many students are in that social studies class? And so when you look at these line plots, what you're doing is each dot represented on the line plot represents a student. So for example, a student in the class said they have 0 siblings. Another student said they have 0 siblings, and another one have 0 siblings. So there's 3 students that have 0 siblings. So this represents, each dot represents 1 student. If you keep looking, right, if you go over to 1, there are 3 students actually that said that they had 1 sibling. Look at 2. You have also 3 students in class that said they have 2 siblings. 1, 2, 3, 4, 5, 6 students in class said they had 3 siblings. 1, 2, 3, 4. 4 students said that they have 4 siblings. There was no data recorded for 5 siblings, but there was 1 student in class that had 6 siblings. So since each dot represents a student, you can count how many dots are here, so you know how many students were in the class when they were surveyed. So 3, 6, 9, 13, 14, 15, 16, 17, 18, 19, 20. So there were 20 students in that social studies class that were surveyed on how many siblings they have. Okay, so let's look at letter A. Letter A has you just, again, reading the line plot and understanding the data that's there. Letter A says, how many of the students have 6 siblings? There's only 1 student that has 6 siblings, that 1 dot. Okay, so 1 student. And then letter B, how many students have no siblings? 0 siblings, right? So we come back up, and this is the first thing we talked about. There are 1, 2, 3 students there that have 0 siblings. And then letter C, how many of the students have 3 or more siblings? 3 or more. So I'm going to cover up less than 3. and you're going to focus in on 3 or more. So 2, 4, 6, 8, 10, 11. 11 students, if I count each of these dots here for 3 and more, 11 students have 3 or more siblings. Okay, so number 1 was really just reading the line plot, the number line with data, and understanding what each dot represents on there. Okay, let's keep going. Okay, number 2, same thing. So the resting pulse rates were recorded for 16 boys in gym class before they exercised. So the line plot here shows the results. So they tell you there were 16 boys that they recorded their pulse rates. You should be able to count and make sure that there are 16 X's, data points on this line plot. So 2, 4, 6, 7, 8, 10, 12, 14, 16. Yep, it's correct. So now again, you have to remember, they didn't use dots this time. Sometimes you're going to see X's that are marked to represent data, and that's okay too. And so remember, each one of these is going to represent one boy. So when I look at 79 as a resting pulse rate, there were 2 students, two boys in gym class that had that. At 80, 1, 2, 3, 4, there were 4 boys that had a resting pulse rate of 80. 1 boy had a resting pulse rate of 81, and so on. So letter A, what is the range of the pulse rates? So remember when we were looking at yesterday, range as part of our central measures of tendency. Range is where you take the highest number, the max number, minus the lowest, the min number. And so we are going to do that now. So we're going to do max minus min, or really that's saying high minus low. You see it worded both ways. Okay, so if I take the highest pulse rate, resting pulse rate, it's 85. And I'm going to subtract away from that the smallest pulse rate, the min, 79. 85 minus 79. Okay, so subtract those out. And when you do, there's a range of 6 pulse rates. Okay, which makes sense. If you look at the line plot itself, 1, 2, 3, 4, 5, 6. There's 6 spots on that line plot where data was recorded. There's a range on that line plot of pulse rates of 6. Letter B, how many boys had a pulse rate over 81? Over 81. So we don't count 81, okay? So we cover that up, and you're counting from 82 over. 2, 4, 6, 7, 8, 9. 9 boys had a pulse rate of over 81. Letter C, how many boys had a pulse rate of 83? Exactly at 83. 1, 2, 3, 4. 4 boys. So again, this front side here, and I forgot up here to put a title on this one. We can just call this gym class, or you can call it pulse rates in gym class, resting pulse rates. Usually they should have titles, so I skipped that part, sorry. But these line plots, the purpose on this front page is to just understand how to read it and where this data is placed, and just seeing the frequency of where data is falling on a number line. Now, we're going to keep going, and we're going to start to look a little bit more with mean, median, and mode. So we're going to flip it over. Oops, and look at that. Letter D. Letter D goes with the previous one. My fault. So how many boys had a pulse rate of at most 82? We got to go back and look at that. At most 82. At most. Okay. So if we're talking at most 82, that means everything to the left and 82. At most means it can't go any higher than 82. So you're counting these students, 2, 4, 6, 7, 8, 9, 10. There were 10 boys here who had a resting pulse rate of at most 82. 10 boys. That snuck on the back there. Sorry about that. Okay, number 3. The heights of 20 basketball players in inches are given below. So there's 20 heights here in inches for basketball players, 20 of them. Now it says, letter A, make a dot plot using the number line below. So I give you a number line, started it out, and we're now going to use it and create that dot plot, that line plot based on this data. So I'm going to use dots this time. And usually when you create a dot plot or a line plot, once you take a piece of data and put it on here, like I'll cross it out. So 68, I'm going to put a dot at 68. Okay, so 68 inches. One basketball player is 68 inches. There are 2 at 70. So I'm going to go over to 70 and put 2 dots there. 2 players at 70 inches. There's a player at 71, so a dot there. A player at 75 inches. Okay, remember each dot represents one of the players. There's a player at 80. There is a player at 81 inches. 82. 84. 75. So this would be the second player at 75 inches. 75 again, 3 players. There's another player at 80, so now we have 2 of those. Another player at 75. Player at 77. Another one at 75. So look at how many basketball players have that frequency of height there at 75 inches. 80. 83. Another 80. So that one's getting up there too. 71. And 70. So what you should do is also just double check, make sure you have all 20 on here. So count and make sure you didn't miss one. Otherwise, your line plot, your dot plot is going to be misrepresented. So 2, 4, 6, 8, 10, 9, 10, 12, 14, 16, 18, 20. I got them. So just double check and make sure you have 20 on your sheet as well. So you can create a title here. I would say basketball players' heights. That's just one possibility to represent your line plot, your dot plot. Okay, so let's do some follow-up questions here. Letter B. What is the spread or range of data? So the highest minus the lowest. The highest minus the lowest. So again, I'll say you can call it max minus the min, or high minus low. And so the highest basketball player in inches, the tallest, I should say, 84, minus the shortest player at 68 inches. Not that 68 inches is short by any means, but we're going to take that high of 84 inches, subtract away the low of 68 inches. So 84 minus 68. You should see a range of 16 inches within those 20 players. So 84 inches, you're talking someone that's 7 foot tall, right? And that's one person on that team is 7 foot tall. And then the lowest at 68 inches, you're talking just higher 5 feet, like closer to 6. And so, again, you're looking at that range, the range between those heights, 16 inches. Okay, letter C. What is the mode of the data? So mode, this is a central measure of tendency. And so you're looking at the most frequent height on that basketball team. So if you do, we talked about this as I was plotting this out, 75 inches is the mode, the most frequent height. You have 5 players that are that tall. Letter D, how many players are greater than 70 inches tall? Greater than. So you don't include 70. It has to be taller than 70, right? So you cover that part up and you look at everything to the right of 70. And really, I mean, if you look, there's only 4 players under 70, 70 and under, which means if there's 4 players 70 inches and under, and you have 20 players on the team, that means there are 16 players that are greater than 70 inches tall. Okay, so again, they're approaching 6 feet. Now, what I'm going to have you do, I'm going to have you add to this right now. We're going to do letter E, and I'm going to have you find the mean. I want you to find the average height of this basketball team. Average height. And I'm also going to have you find the median. Okay, which is that middle number. So, you know, with your average, with practicing that yesterday and finding the mean, you have to take all of these values here, every single one, everything listed up here. If I scooch back up here at the top, all of these, add these together and then divide by 20 because you have 20 basketball players. So you're going to do that right now. This is where your calculator comes in. I'm going to put divided by 20 here because we know how many players there are. Right now, find out how many total amount of inches you have here that we're going to divide by 20 and get that mean. Okay, so when you add that together, total amount of inches with all those basketball players is 1,522. And if you divide that by 20, you're going to have an average height on that basketball team of 20 players of 76.1 inches. 76.1 inches. Now let's do the median. So the median, remember, is the middle number. And so you're going to have to determine what that middle value is. So here's how I usually work it out on a line plot. Okay, I work from both ends here. The median is the middle number. I'm going to use my fingers, and I'm going to kind of approach from both sides where that middle value, that middle plotted point is going to be. Now there's 20 numbers. That's an even amount, which means we're going to have 2 middle numbers here in just a minute that we have to look at. So I'm going to slowly creep in here and take a point away from each side. That goes away. And now this one goes away, and this one. And so my 2 middle numbers are 75 inches, which works out perfect. I don't have to worry about adding those together and dividing it by 2 to find that middle number since they're both 75 inches. The median, the middle height is 75 inches. So one thing I just want you to notice too on this graph, just notice how spread out this data is called, or this data is, sorry. It is really spread out on the number line. It's not clustered together, which is fine. Sometimes when you see line plots, in fact, let me look over here for a second. Like on number 1 and number 2, these are clustered. The frequency is closer together here based on those surveys or the data that you have. Where here on the basketball players' heights, it's just more spread out. And again, that's okay. It just depends on your survey or what data you're looking at. All right, so we're going to head to number 4. And I'm going to have you try this one. So what I want you to do is take this data. This is the ages of 22 students in a karate class. And so you have 22 values here, 22 numbers. And you're going to make a line plot using this number line below. So you can use the dots like we did on number 3 when we did the basketball players. Sorry, right here. You can use the dots. Or you can use X's like it showed you in number 2. So go ahead and use the 22 students. These are their ages. Okay, so 11 years old, 5 years old, 9 years old, and so on. Plot those on here. And go ahead and also answer B, C, and D and see how you do. I'm going to pause the video. You can work these out with somebody in your pod or a partner if you'd like, and then meet me back to see the answers. Okay, so let's see how you did. So this is what your line plot should look like. Now, again, you could use dots or you could have used X, as I said. I just put a title up there about karate class. And again, these are the ages of the students in the class. So you make sure when you plot this that you have 22 markings there. Just always double check that you have the same amount that you started with your data. Letter B, what is the range of the data? Well, you have 13-year-olds in class. That's the highest, the oldest age. And you also have a 5-year-old in that class. So that's the youngest age. So subtracting those, you have a range of 8 years within that karate class. What is the mode of the data? So the most frequent age. So that's 11 years old. There are 4 students in that class that are 11 years old. And so that is your mode, most frequent. Letter D, how many students are at least 10 years old? At least. So 10 and above. There are 11 students that are 10 years old and above in that class. The last thing I'm going to ask that you do here is find the mean and the median based on your data. So you can use the values, the data set up here, or you can use your line plot to find it. Do these two next, and then I'll meet you back with the answers again. Okay, last part. So the average age is 9.5 years old. So if you would have added all those ages together, you should have gotten a total of 208 divided by the 22 students that are in that karate class. And again, average age in that class is 9.5 years old. Now the median, we have an even set of numbers again. So since there's 22 numbers here, you have to realize that when you have an even set of data, you're going to have 2 middle numbers to begin with. And so you can either go on the number line and kind of go from both ends and find what those 2 middle numbers are, or you can come up here and order this set of numbers from least to greatest and find that the 2 middle numbers are 9 and 10. And so that gives you 19, and you have to divide that by 2 to get that middle value. It happens to also be 9.5 years old. And sometimes that happens, and that's okay. It's not always going to happen. But the middle number and the average age in that karate class is 9.5. So this data set here, this line plot, this is more clustered together. Your data looking at that karate class is more it's not spread out, right? It's all clustered into almost, between 5 years of age and 13 years of age. So this kind of ties up line plots and using some of that central measures of tendency to read and understand and interpret and construct them. And so this will end for chapter 10 as far as lesson 1 goes. Now, I had said afterwards on the agenda, once this is done today, you're just going to go back to number 2 with the time remaining and keep working on getting ready for your final exam. There are some chapter 6 quizzes, problems, 1-step and 2-step problems you can try now in Google Classroom there. And so the rest of the time is yours. Again, like I said earlier, have a great extended weekend, and we'll see you back on Tuesday.